Here, we're looking at the basic ideas of integration. Okay, in a nutshell, we are looking at integration, and I want to look at, we're going to spend time to look at the in-depth knowledge. Uh, we're going to look at we're going to have in-depth understanding of integration. Okay, so without wasting time, uh, basic ideas of integration. And I want to tell us that integration is opposite to derivative. So whereby we can call integration as anti-derivatives or anti-differentiations. And I'm going to show to us now how integration is an opposite to differentiation. Okay, let's look at this. The general, the standard formula for integration is this. When you have this function, this is symbol for integration. Okay, then you put the element of the integration, the x. Okay, the standard form is the power you had plus one, and then over what you have here, n plus one, then plus the constant of integration. C is the constant of integration. Okay, so this is the format, this is the standard rules for integration. Okay, now I want to show how integration is an opposite of differentiation. Let's go. Let's say you have ddx of probably 3x squared. Okay, yeah, you know, derivative of this one will give us, we know is what? Is 6x. Okay, 6x, which is the 2 will go to the front, that's 3 times 2, that's 6, and then the power minus 1. Okay, then can you multiply both sides by what? By the dx. So you have d of what? 3x squared equal to what? It's 6x then dx. Okay, sorry, I don't want to put the okay. So the multiply both sides by what? By the dx. So you have d 3x squared, okay, equal to 6x dx. Okay, can you now bring in the integration sign now? Integration sign to both sides, And I want to tell you, when you have d of a function under integration, it's going to give you that specific function, and that's what? 3x squared equal to what? Integral what? 6x dx. Okay, so you can now see that. Look at where we started from. We said that the differential coefficient of this is this. Okay, so when you now integrate your the other side, okay, when you integrate that, it's going to give you back what? The differentiation. So you can see it's an opposite to each other, and that's what we call it anti-derivative. Okay, let's take another example. We also know that d dx of sine x is what? Is cos x. Okay, can you also multiply both sides by dx? So you have d sine x equal to what? Cos x dx. Can you integrate both sides? Put the integral sign to both sides, and the d of a function will give you what? The function. So that's sine x equal to what? Cos x dx. So you can also establish that the integral of what? Cos x is what? Is sine x. You can see they are opposite to each other, from sine to cos, and then from cos back to what? Back to sine. Okay, let's take another one. Then after this explanation, then I will give the standard form, standard table for integration. Let's look at another one. Integral of ddx. Let's see ddx of cos x will give us now, we know is sine x. Okay, then multiply both sides by dx. So we have d cos x equal to what? Integral minus outside sine x dx. Can you also move this minus to that side by multiplying both sides by minus? So you have d minus cos x equal to what? Integral of what? Sine what? Sine x. Okay, dx. Okay. So in that case now, we can now have now integrate both sides, put the integral sign to both sides. Okay. If you do that, d of a function is that function minus cos x equal to what? Integral of what? Integral of sine x dx. So what we are saying now is that the differential coefficient of cos is sine. Okay, and when you integrate this right hand side, you get back this side. So that is just you have established the relationship between differentiation and integration. Let's take another one. We also established the differential coefficients ddx of tan x is sec square x. The left hand side differential coefficient of this is given sec. Okay, and when you integrate sec also, you get back the what? You get back this tan x. So that's the relationship between integration and differentiation. Let's take another one. 5 d dx of ln x of log to base e. The differential coefficient of this is 1 over x. Okay, so we can say d ln x equals to 1 over x dx. Can you also integrate both sides? If you integrate 1 over x, then d of a function under integration will be that function. That will be ln x equal to what? Equal to this. So integral of 1 over x is what? Ln x. So that is the relation between differentiation and integration. Okay, so that's let me take another one before the table. The d dx of arctan x. Arctan x is what? 1 over 1 plus what? S squared. 1 plus S squared. Okay, so d arctan x equal to 1 over 1 plus S squared. Okay, 1 plus S squared. Dx. Can you integrate both sides? Integrate both sides. So integral of d of a function is that function. Arctan x equal to what? Integral of 1 over 1 plus S squared dx. Okay, so integral of 1 over 1 plus S squared is equal to what? Arctan what? Arctan x. You can see the left to right, and then the right also giving you back your left. Another one again, that's this is 6. Let's take another one, 7. I'll just take one more. Integral of ddx of arcsin x. Arcsin x is what? Is 1 over 1 minus 1 s squared. Okay, take this will be equal to d arcsin x equal to what? Multiply both sides by dx. So we have 1 over 1 minus s squared dx. Then integrate both sides. If you integrate both sides, d of a function under integration is going to give you that function. That will be arcsin x is equal to what? 1 over 1 minus s squared dx. So what we are saying is that you can see from left to right. Okay, then you can now see the right also giving you back your what? Your left. And that's why we say it's an opposite to the differentiation. Okay, so that's just that on that. That's that on that on the relationship between differentiation and integration. So the next thing we're going to show now is to give us the standard table for integration. Integral of x to power n. Okay, and when you use this your integral sign, okay, there must be an element of that integration dx. Okay, then this is the functions of x, and that's what we have dx. If your function is maybe another thing, maybe theta, it will be the theta for the element of integration. And it's very simple. Just take your function, and then the power plus 1. And whatever you have here, then you divide it by what? By that power. That's number 1. Number 2, integral of sine x dx is equal to what? Minus cos x. Then you put the constant of integration. Put it there. I've shown this one on the short. I've shown it not quite long. We got sine to cos. Okay. Then another one again is the integral of cos x dx give us what? Sine x. Then plus the constant of integration. Okay. What again? 4. For exponential function ex dx give you that same function plus c. But there is an exception to this. When we get there, I'll tell you. The exception is just, let me mention it briefly. The exception is just, let's say for example you have the integral of e to power 2x dx. Okay? It's very simple. You write the question again, the function. Then you now divide by the derivative of the power, which is 2. That's 1 over 2. Divide. If you don't want to use 1 over 2, just say, that will just be equal to, that will be equal to over 2, and then plus c. Okay? Exactly now. So that's just the exception to that to this because the attachment here is 1. Okay, or the coefficient here is what? Is 1. So it has no effect on that. Exactly. So that's that on this number 4 is integral of dx over s squared plus a squared plus s squared. If you have this, this will be arctan. Then one of these x and one of this over a. Okay, then you divide by what? By the constants. Divide by the constants and then plus c. Plus c. We're going to see example on this shortly. Okay, that's arctan x over a. Then you divide by the constants. Your a is a constant. Okay. Yeah, next on the list is integral of dx over a squared minus s squared. That's that on the left. This will give us arc sine x over a, then plus c. On the list is integral of 1 over x dx. Okay, that will give us what? ln x plus c. So that's that on this table. This table still continue, but we are going to pause for now and see applications to this table. I've shown all this I've shown all this how we got this working from differentiation to integration. Okay, let's see examples. Is this? I want to look at the integral of the first example I want to look into is integral of sine squared 1 over. So what we can do now is for us to go to look at this. Let's say we have cos x is equal to 1 minus 2 sine squared x over 2, okay, or 1 over 2x. This. We're given this identity on our half angle and double angle. We've discussed that. Okay, so if you're having any challenge with that, you can please check the video and watch it. We're giving in-depth knowledge on this double angle half angle. Okay, if it's 2x, if it's cos 2x, it will be 1 minus 2 sine square, half of this angle. That will be what? That will be x. Okay. This one is 1, so half of that is what? X over 2. Okay. So that's that. So what we now do is just for us to make this one the subject. not to make this one the subject. This is what we need to make it the subject. And then we can move this one to the other side. So we have 2 sine square 1 over 2 x equal to 1 minus cos x. Then we divide by 2. So we have 2 sine square half x equal to 1 over 2 into brackets half minus cos x. So we can change now. We can now have now the integral of sine square half x dx is equal to half integral of half minus half cos x dx. So that's just that. Then we can integrate that. That will be equal to this one integral of. So this one is going to be integral of half dx, which is the half can go to the front, which is half dx minus this half also can come outside half the bracket cos x dx. That will give me half. Let me repeat the question again. And finally, I have integral of dx is what? Is x. Yeah, integral of dx is x. Then minus half. Integral of cos x is what? Is sine x. And then plus c. So that's that on that question. That's that on that question. Okay? That's that on that question.